Hello everyone, welcome to the next tutorial wherein we'll be learning about how to visualize the data that we've been talking about so much in the last few tutorials. So there are various Python packages or libraries that are available to visualize the data. So in this tutorial we'll be learning about two important libraries. One is Matplotlib and another one is Seaborn. So I'm going to show you how to create a very simple graphs or plots using the data. And of course, there is no specific end to the customization of the plots or how we can make these plots to look more attractive. So I'm just going to give you a basic tour of how to plot graphs using different packages, and of course you're encouraged to explore further depending upon your taste. So Matplotlib is one of the commonly used and widely used Python libraries. So let's begin. Now Matplotlib needs to be installed like usual. So here, let me just start off again, and I'm going to take it as run as administrator. Just click yes, and in case if it is not installed, you have to matplotlib. Oh, sorry, I have missed. Conda install matplotlib, and there you go. You just click enter, and the system is going to start the installation. But since in my case that I already installed it, I'm going to skip the step. But in case if you don't have it installed already, then you're free to continue this process. So now that it has already been installed, I'm going to continue further with import matplotlib.pyplot as PLT. So this is a short form because every time I'm calling the entire thing is very difficult, so I'm going to give it a short form and name it as PLT. And along with that, I'm going to import another package, that is NumPy, about which we have already learned. So now let me just import these two successfully into our Jupyter notebook. And after having done that, now any plot, you need an x-axis and a y-axis. So let's create some data which we can use for plotting. Now in this tutorial I'm going to try to plot a simple sine wave or a cosine wave. So x is equal to numpy dot generate a range of angles which lie between 0 and 2 pi. So here we are using the command numpy.mat, because mat the symbol pi actually belongs to the numpy library. So I'm trying to call the pi from the numpy library here. And so I want to actually generate a list of angles between 0 and 2 pi at every 0.05 interval, and that's it. So the x values are ready. Now all I just need to do is find the sine of this angles or cos of these angles and then just plot it right away. Okay, so let me numpy, so this cos, sine and all of them are within the numpy library, and that is why we had to import numpy into the Jupyter notebook first. So now coming to the plotting part. So now we have x and y ready. Let's get into plotting. So we call matplotlib.pyplot as PLT first, and we will say PLT plot x comma y. So if I just give it like this, you can see that a sine wave has been created. But I know how this plot has come up, but someone else who is seeing this may not understand or may not be sure about what exactly this plot is trying to say. So for that, we need to add some explanation into this graph, such as what is the x-axis, what is y-axis, and so on. So I will give it as plt.x label, and the x label is going to be angle for me, and y label is going to be sine. And also I can give a title for this plot because that would explain a lot, and I'm going to give it as sine wave. So if you see now, it has changed. And also you can change the font of the labels here, the title, and you can change the color of the line here. You can change the weight of the line. It is up to your customization, and so I'm going to leave you to, and I'm going to encourage you to do it. And I will just show you the basics of how simple plotting can be done in Python. So now that I have created a simple sine wave, I will also try to create a combination of sine and cosine. So here I'm not going, in the previous example we actually generated x and y separately and then we have plotted. But once you get used to this, you can directly generate and plot at the same time, like how I'm going to do here. Now we have already generated an x value, so I'm directly going to say numpy sine of x, and I'm going to mention that the label of this is going to be sine. I'm going to explain little later as to why I'm mentioning label here. And same way, I'm going to say plp, please plot numpy dot cos of x, and this is actually cosine for me. And then if I'm just going to plot this along with the label, here I can't give it as, so I will say cosine or sine, and if I just click it, I know that now this is representing a sine and a cosine against the angle. But we don't know which is a sine wave and which is a cosine wave. So in order to make it very simple, I'm going to add another command called as plt.legend, and I'm going to mention where this legend needs to be located in the entire plot. But just for the sake of understanding, let me just go, and as you can see here, the legend has been automatically kept at the lower left corner, but we can also make it to come in the center by using the term location is equal to, let me just give it a center and try. See, the legend came exactly in the center, or you can call it as upper. Okay, that is not a syntax. What we can do is center left, center right, and so on. So let me just try center left here, and you can see that it is here. So depending upon that, in fact, you can increase the size of the fonts here and so on and so forth. So this is how you can combine two plots into one. So apart from this, we can create subplots as well. So the syntax for this is very simple, but you just need to get the hang of it. Fig.axes. The reason why we say this is because we should be able to call each of them individually. So I will use fig.axis, then I'll say plt.subplots, which is a command for that, and fig size. So the reason why we use fig is that we are mentioning the fig for the entire plot. So I want the size of the plot to be 15,8, and I want the number of rows to be 2 because I'm trying to plot these two graphs one below the other, and number of columns to be equal to 1. So this is a general description that I'm giving it to the program first. Then I'm going to give a separate set of instructions for each of these subplots. So here I'm trying to create a subplot which consists of 2 rows and a single column. So basically 2 plots I'm trying to create. So I'm going to give a separate set of instructions for each of the plots. So I will always give it as plt.subplots 2, 1, that is 2 rows, 1 column, and the first plot in this scheme. And I will say plt.plot. I will directly take it from here and I will plot it here. So that gives me that, and then I will need my x label and y label, and I will take the title as well, which is very easy. So like this, I have given a set of instructions for the first subplot. In the same way, I can give the similar set of instructions for the second subplot, but I am going to change the number here as 2. This is the second plot in that particular scheme, and I want it to represent cos of that angle, and it's a cosine wave, and same here. So now if I run this, okay, there was some problem. Did you intend to use a plot? Yes. What? Where did I go wrong? Okay. The command what I have made is plt.subplot, and now you can see that we have two subplots which has been created. But there is a small discrepancy wherein the title and the axis label is kind of flushing into each other. So there we have a separate command for that, which we call it as plt.subplots underscore adjust, and I'm going to say that I want my horizontal spacing to be 0.5. And now you can see that the two plots have been separated. So this is how you can create any number of subplots. And also, because here if you want to change the color line, then it's very simple. You just have to give R minus and give it a go. Sorry, I missed a comma. And you can see that cosine wave is red in color and sine wave is blue in color. So this is very simple because sine wave and cosine waves are very easy to recognize, but whenever you have a very complicated data, then it becomes very important for you to mention the type of the wave as well as the differentiation of the different colors. Okay, next is bar graph. This is also quite interesting and very simple to plot, and I will just create an empty list of ages of two people who were part of some survey. Okay, so I've created a list that is data which consists of ages of certain people, and the command to plot a bar graph is plt.bar, open the simple braces, and now I'm mentioning what should come on the x-axis. So I will just give a name of few people, say Sham, Shiv, and Alice, Eva, and sorry, I need one more which I will call it as Sanket. Okay, so this is what I wanted to display on x-axis. I've given 5 names because I have 5 set of values in this list, and comma. Now I'm mentioning the y-axis. Okay, so now apart from this, I want y label to be mentioned as age in years. So after having done that, we are good to go, and we can see that a bar graph has been created. In the same way, scatter plot is also quite extensively used, and I'm going to show how a simple scatter plot can be done and also how you can improve the aesthetics of a simple scatter plot. So for that, first let us begin by creating a random data set, and I'm sure we are already familiar with how to create a random number. So numpy.random.rand of n, and y is equal to numpy.random.rand of n. So we are just trying to create a list of random numbers for x and y, and then I am going to create another variable, or okay, just for the sake of the simplicity, let's just go with this, and I'm going to say plt.plot as usual x comma y. But if you want it to be a scatter plot, then you should always mention like this. So it's going to take it as x comma y, and this is how I want my data to be represented. So as you can see, a scatter plot has been created, and I'll just keep my plt.x label as just x, and in the same way I'm going to keep my y label as just y. So this is how a simple scatter plot is actually plotted. But if you want to improve the aesthetics of the same plot, I'm just going to add a few more commands here, and one is colors is equal to numpy.random.rand of n, and I'm going to show you why I'm trying to create something here, and I will say plt dot scatter. This is another way of creating the scatter plot, wherein I'll give x comma y comma C actually stands for colors, and alpha stands for the level of transparency you want in these colors. If you want a very light and translucent color, then you just have to reduce the value of alpha, and if you want a solid bright colors, then you just have to increase towards 1. So I'm going to go with 50% transparency, so this should do it, and you can see that even, in fact, even the colors that have been generated are quite random and they do not follow any specific pattern. But in case if you remove this command, it is going to go back to being the same old single color plots. So this is how you can improve the aesthetics as well. So again, sorry, here you just have to give it a C as color. Okay, so this is why I wrote a separate command for colors. Now this is how we can create a simple plot, or we can improvise on a simple scatter plot. Another widely extensively used plotting package is Seaborn, and this is extremely useful whenever you are trying to visualize the data. So I'm going to import Seaborn as SNS, and in case if Seaborn has not been installed in your desktop, you have to repeat the same process. Go Kunda install Seaborn, and you can install it. So now I'm going to first take a file. So that is why I've imported pandas as well, because I want pandas to read me a file which is stored on my system, and the location of this file is quite different from where this Jupyter notebook is operating. So I'm going to copy the location from here and I'm going to paste it, and the name of the file that I want to load is flatfile.gmpes.xls x, and so I have basically loaded the file now. So this is a very big data file, and I don't know what all this data file basically consists of. So if I want to just find or perform some statistics on this data file, Seaborn comes very handy, wherein I call it using the short term SNS, and I will say dist plot. So dist plot basically tries to give us a cumulative distribution of any particular panda C. So I'm going to call in one particular column from the entire data frame. So this has been stored as a data frame now. I'm going to see how this earthquake magnitude has been distributed throughout. So if I run, it is going to show it to me that more number of earthquake events in the magnitude range of 4 to 5 is present in my input file when compared to the higher magnitude or lower magnitude ranges. So Seaborn actually helps us in finding the distribution of different independent variables. So in the same way, we can also create a simple bar graph, which is we call it as histogram in uh, or statistical terms. So I'm again going to use the same command, this plot of ff of vs30, and there are a few set of commands which you can actually familiarize yourself depending upon the type of the plots that needs to be displayed. Bins is 25 I'm giving because I want the entire data set to be divided into 25 bins when it is creating an histogram. So now I will say p1 dot set y label as number, and like I said, how you can change the font as well. So I'm going to go with font weight, and I will give that as bold, and then I'm going to give the font size as 12. Okay, so this is how you can customize different aspects of plotting. So in the same way I'm going to do for X label as well. And basically my x label is PS30, that is shear wave velocity we call it. So PS30, and this is measured in meters per second, and I want the font weight to remain same. And now the plot is created, and it shows an histogram, and it says how many number of records we have of higher VS30 and so on. Now if you want to save this figure, then it is very simple, PLT save fig. So this is one of the commonly used things, because after doing a certain set of statistical analysis you would want to save it somewhere, right? So that you can export this and use it in some reports or some journal and so on. So I'm going to save it as a plot underscore 2.jpg, and in fact you can also set the DPI, and 300 is considered as the HD quality level. So I'm going to take my DPI as 300, and if I run this, this is going to get saved. In the same way, we can also see a joint distribution. Okay, so it's very simple again. I'm going to say p1 underscore 1 as SNS dot joint plot is the new syntax, and I will say I want x to be ff of distance, because ff of distance is a particular column in the data frame that we imported, and I want y to be ff of magnitude. Okay, I want it to be earthquake magnitude. So it's very one more shortcut is whenever you press a tab, it will automatically list the number of column names. We don't have to remember the column names to call them as well. Now next, data. From where should this actually take the data? That is from the file ff, which we have loaded it from external source. So now after having done that, we can do little bit of aesthetics by using the command set axis. So here every time the reason why we saved the plot as p1 underscore 1 is every time we don't have to call the entire thing, and we can directly just call by its variable name and do all set of operations. So set axis labels, as I want it to be, my x-axis should be epicentral distance in kilometer, and I want my y-axis to be magnitude and MW. And again we can change the font size and font weight. I'm going to copy it from here directly and paste it here. Okay, and again we can save the plot depending upon our convenience. So like you can see here, it has shown a joint distribution. So we can see how the data file that we loaded is distributed magnitude wise as well as the distance wise. So this shows the histogram of the distance, and this shows the histogram of the magnitude, and also we can see the joint variation of these two input parameters. So this is how Seaborn is basically used for visualizing large data sets, and I hope you will continue and explore more possible plots from Seaborn, and I hope that you found this tutorial very helpful. Bye bye.